Hi everyone, welcome to today's class. In this class we will be looking at solution to the assignment sent to you. So let's do that quickly. Now we have this question. I want to believe you all have it, and if you can't, you can always go through the questions after the video. Now let's see. In this question we are asked to calculate the radius of its circular base. The concept here is that you are actually forming a cone from a sector. Now, whenever you are solving questions like this, it is very important. It is very important for you to understand some basic concepts. And one of them is this. If I want to get the radius of its circular base, there is a concept, and that concept is the curve, or let's say the circumference of the circular base is equal to the length of an arc. Now don't forget that this is a cone. And this is the radius. Now if I want to get the radius of this base, all I have to do is that I need to use this concept, which is the circumference of this base is equal to the length of an arc. This is a sector. Now from here, if this is AB, then from this point to this point is the length of the arc. So if I want to do this, all I have to do is, now what is the formula for circumference of the circular base? Let's put base here. Very good. So what's the formula? The formula is 2 pi r. That's the circumference of a circle, equal to the length of an arc, which is theta over 360 times 2 pi r. But the r here will be the what? The slant, will be the slant height of this cone. Please always remember that the base here, the radius that you are going to put in the length of the arc for the formula for the length of the arc must be the slant height of that cone. So slant height. So if that is the case, I think 2 pi can cancel 2 pi. Then I will be left with r. And that means my r will be equals to theta over what? 360 times the slant height. And if you check this question very well, you were told that a sector with an angle of 72 degrees at the center is cut off from a circular piece of paper. Now let's see, this is a paper, and in this paper you have a sector cut off that has an angle of 72 degrees. That means the remaining angle here will be what? 288 degrees. And if that is the case, you were also told that this piece of paper has a radius of 70. That means here is 70. This is 70. This is also 70. So if that is the case, and you know if this is the radius of the minor sector, then it will also be the radius of the what? The major sector. So in this case, if we are using the theta over 360, the angle that we are going to be using will be 288. But if the cone was actually formed from the sector that was actually cut off, then you are going to be using 72 degrees. But we're actually forming a cone from the remaining portion. The remaining portion, and this is the remaining portion. This is the angle, 288. So this is the remaining portion, and that is where, and that's the angle that we are going to be using. So let's quickly go into that. So that will be r equals to what? 288. All divided by what? 360 times 70 degrees. And if you do your calculation very well, the radius will be equal to 56 centimeters. Will be equal to 56 centimeters. Now let's see, the height of the vertex above the base. The height of the vertex above the base. Now don't forget that this is the cone. We actually want to calculate this height. And if I want to calculate, if I'm calculating this side, this will be an angle 90 degrees form. So if I want to make a sketch of that diagram somewhere here, I'm going to be having a right angle triangle with height h, where the base radius is what? 56 centimeters. As you can see, we've calculated it here. And the slant height was 70 centimeters because the radius of the sector automatically is the slant height of the cone. And if that is the case, I'm going to be using my Pythagoras theorem. Pythagoras theorem. And if you are doing that, it's going to be the hypotenuse squared, which is 70 squared, will be equals to h squared plus 56 squared. And if you make your h the subject of formula, it's going to be the square root of what? 70 squared minus 56 squared. And if you do that very well, your h will then be equal to 42 centimeters. Do it very well. That's what you will get. 42 centimeters. So we move on to the third one, which is the area of the curved surface of the cone. And the curved surface area of a cone, if you go through the formulas given, is given as pi RL. And what is pi? 22 over 7 times 56, which is the radius of the base, then times the slant height, which is 70 degrees. And if you do your calculation very well there, you are going to get 12320 centimeters squared. That is 12,320 centimeters squared. And that will be your answer.